Hello, good to see you all again. Today we are going to discuss regarding the high pressure separator exposed by the fire and to analyze whether the safety valve able to manage this pressure during the fire case or not. So actually for the preface, this the flow is going from this stream number one and then controlled by flow control valve. And in high pressure separator, the multi-phase flow will be separated. The gas phase going to top and the liquid phase will going downwards. For the gas phase, consisting two stream, the stream number one is going to gas treatment, and this flow is controlled by the pressure control valve to control the pressure at the HP separator, high pressure separator. And the second one represents the line of pressure safety valve. And for the bottom or the liquid phase, there is liquid control valve controlling the liquid percent of the separator. Then the liquid will go into the low pressure separator. At the beginning, we have to specify the component. Then we have to specify the fluid package. I chose Frank Robinson since we are dealing with these non-polar components. First one, you can specify the feed stream composition. You can use your own composition or follow this composition. For the operating condition, you can follow me as you can see here, and afterwards you will be at the valve here, and at the rating tab you can follow me for this valve specification. Then for the pressure control valve, as you can see here, you can follow me using the specification of pressure control valve, and for liquid control valve, as you can see here. And since we are operate the system at about 450 pound square inch, here you can set the pressure safety valve about 500 pound square inch, and for open pressure we assume that this relief valve or safety valve will full open at 21% of the set pressure, approximately at 600 pound square inch. For the orifice area, you can use D with the orifice area about 0.1 square inch, and choose the equal percentage type. Then we can add the control loop here. You can add using the PID controller and connect the target variable or object is the open percentage of this valve, and then for the process variable is the molar flow itself. Then you can choose the reverse. You can follow me regarding the specification of this control loop. Then for the pressure control valve, which is maintaining the pressure of the high pressure separator, you can use direct, since if the pressure increase, the opening of this valve is increased as well. You can use the specification. Then for the level controller, the same as before. Here is the opening percentage of this valve, and the process variable is the liquid percent level of the separator itself. For the parameter, you can refer with the specification. For the action will be direct, so the valve will open once the liquid level is going to increase. And the mode auto, you can refer to my specification here. And for the number indicates in here, you can use the show table option, and you can specify the parameters you want to monitor at each stream. Then you can specify the diameter of your vessel. I specify about 3 cubic meter here, and then let the HYSYS calculate the diameter and the length of this vessel. But you can use your own dimension of your vessel to represent your actual vessel in here. And I chose the horizontal cylinder. And for the initial value of the liquid percent, I specify the 50% here. And for the fire itself, I assume the fire will give the duty towards the vessel. So I add this energy stream to the vessel. Here I name it as fire. And for the diameter, you can use this arc import variable, and then you can choose your HP separator, and you can specify what parameters you want to select in this spreadsheet. For the diameter here, you can see vessel diameter, and for the length, you can use here. And for the weighted area, you can use this formula. I assume this conservative assumption, which that the vessel weighted area about 50% of the vessel height itself. And for the duty of fire, I obtained this from the API 521 recommended practice. You can use this formula as well. And for the multiplier, I specify 0. So at the beginning there is no fire exposed to the HP separator, and then after several times in the study the fire will expose, so the multiplier will change to 1, and then the fire will the same with this one. Perhaps I can demonstrate how to connect this energy stream. Okay, you can delete itself and then create the new one by connecting the stream and name it as fire. And afterwards, you can export this cells value, export formula result to this fire heat stream and choose the heat flow. So that's all to connect this fire with this energy stream. For the flare heater, I specify nearly atmospheric pressure to represent the actual condition of flare heater system. Then we will specify the event scheduler to specify what will happen in the study. So you can add the schedule 1, which consists of sequence A. The sequence A itself consisting of 2 scenarios. The first one, the fire scenario, the scenario where the fire is initiated. So I decide the fire will initiate it at minute of 30, and the action list itself is the fire to check the B8, change the multipliers of fire by 1, as I mentioned before in the spreadsheet function. And during the fire case, the pressure control valve will be closed, level control valve will be closed as well, and the flow control valve is also in closed position. And afterwards, we assume that the fire is extinguished after 3 hours by fire protection system. Then we can add the strip chart here, and the things I want to monitor is the vessel temperature, the pressure, and the opening percentage of this PSV, pressure safety valve. So the pressure will operate normally, and then at the minute of 30 the fire will be initiated, and we will see what will happen. Here, to adjust the strip charts here, I chose the vessel temperature, change it to size number 3 for the PSV opening percentage for the vessel pressures, and using this automatic auto scale and axis display, adjust the show all to see all axes that we want to monitor here. So the event scheduler we adjusted before will change this multiplier, the B8 value. Before we change to dynamic mode, ensure the boundary stream already changed to the pressure specification, here indicated by green color. You can use the dynamic tabs and ensure this one is checked, and the flow specification already unchecked. And ensure there is no issue in this dynamic assistant, so we can start our dynamic simulation. You can choose this dynamic mode and go to the integrator, and I want to see the acceleration is 1.05 of the acceleration of 5%, and we can start the event scheduler before we start our dynamic simulation. Then here I want to see the strip charts. I want to change the integrator to 0.1 so we can monitor the parameter, operating parameter, more easily. We can start the run button here to see. So at the beginning the vessel is going normally, and then at the minute of 30 the fire is initiated. Here you can see that the temperature of the vessel is increased, followed by the pressure increase, and after the pressure exceeds the 500 pound square inch, the PSV will be open. Here we can see the PSV working to manage the pressure so the pressure will not increase violently and control near the set pressure. Yeah, as the pressure increase, the opening of the pressure safety valve increase as well. Exceeding 550 square inch, the opening of pressure safety valve about 26%. Temperature is already stable since the containment already vaporized. And after 3 hours, we assume that the fire is already extinguished by the fire protection system, and then the pressure is decreased as the fire extinguished, followed by the temperature as well as the opening of the pressure safety valve as the pressure is already decreased to the set pressure of the pressure safety valve. You can see here that the pressure of the vessel was maintained by the pressure safety valve, so the increment of the pressure will not increase violently. It can be controlled here. So I think that's all about this video. I hope this video is useful and see you on the next video.